Hey there, today we're going to tackle one of the most fundamental tools in machine learning, logistic regression. Now I know, the name sounds kind of complicated, but stick with me. You're about to see how it's the secret sauce behind a ton of the yes or no decisions that basically run our digital lives.
I mean, just think about it for a second. That email in your inbox, a student's final grade. Every single day, all these systems are making countless little binary choices. Is this email spam or is it legit? Did the student pass or did they fail? Is the credit card transaction approved or denied? So how in the world does a machine learn to draw that line in the sand and just make a call? Well, that's the puzzle we're going to solve today.
Okay, so to really get this, we've got to shift our thinking a little bit. We're moving away from trying to predict an exact number, like what a stock price will be tomorrow. Instead, we're diving into the world of predicting simple categories. This is a huge fork in the road in the machine learning universe, and it's where the real magic of classification happens.
In this slide, right here, it nails that core difference. On one side, you've got linear regression. It's awesome for predicting a number that can be anything along a smooth line, like that stock price. But what if you don't need a number? What if you just need a simple yep or nope? That's where our hero, logistic regression, steps in. It is built specifically to predict which of two boxes something belongs in.
So let's properly meet our tool for the job. This is the algorithm that takes a whole mountain of messy data and turns it into these clean, clear-cut choices. It's time to pull back the curtain on logistic regression.
Okay, first thing you got to know, and this is a big one. Even though it has regression right there in its name, logistic regression is for classification. Yeah, it's a bit of a weird name, I'll give you that. Its whole purpose in life isn't to predict a point on a line, it's to sort things into one of two piles. So from now on, when you hear logistic regression, think classifier, not number predictor.
And listen, this isn't just some dusty old thing sitting on a shelf in academia. No way. This is a real workhorse that gets used all over the place. In medicine, it can help figure out the risk of a disease, which could literally save lives. In marketing, it helps predict if you're going to buy something. Its power to just give a straight yes or no makes it so useful. All right, so how does it actually do it? How does it get from a big mess of data to a confident yes or a firm no? Well, the secret is all about turning that uncertainty into a decision. It's about drawing a line. See, the model doesn't just wake up and shout yes or no. The first thing it does is actually way more subtle. It calculates a probability. It looks at all the information it has and says something like, based on what I see, I'm 85% sure this is spam. Or maybe, I'm only about 30% confident this is a good loan to approve. But, a probability. That's not a final answer, is it? We need a rule, a hard and fast rule to make the final call. That 85% is just a number. It has to be translated into an actual action, like, okay, move this email to the spam folder. And that rule, it has a name. We call it a threshold. It's a super simple but incredibly powerful idea. It's just a cutoff point. A really common one is 0.5, 50%. If the model's probability score is higher than that threshold, we say, okay, that's a yes. If it's lower, nope, that's a no. It's the point of no return. And this is a perfect real-world example. To pass your written driver's test in California, you've got to hit 85%. That is the threshold. An 84% is a no, and 85% is a yes. It is a crystal clear, defined line that turns a score into an outcome. And that's exactly what a logistic regression model needs to make its final decision.
Okay, enough theory. Theory is great, but let's see this thing in action. We're going to get our hands dirty, so to speak, and walk through how you actually build and train a real model from the ground up.
Building a model might sound super complicated, but honestly, it boils down to these 4 pretty straightforward steps. First, you need data. We're using a classic flower data set called Iris. It's kind of like the hello world of machine learning. Second, you build the model's structure, its brain. Third, you train it. You just show it the data over and over again so it can learn the patterns. And finally, the big one. You check if it actually learned anything useful.
Now, don't worry, you don't have to be a programmer to get what's happening here. The big idea is that this model was trained for 100 rounds, or what we call epochs. You can think of it like a student studying for a test. For 100 rounds, it just kept looking at that flower data, trying to get better and better at telling the species apart.
So, this is it, the moment of truth. After all that training, after all that studying, did our model actually learn its job? Did it pass the final exam? Let's find out.
We did all the work. We fed it the data. We let it study for 100 rounds. The big looming question is, was it worth it? Is our model now a genius at identifying flowers, or did it totally flunk the class?
65%. Oof, well, it's not great, is it? If this were a test in school, that's a D, barely passing. And you know what? This is a really, really important moment in understanding machine learning. Your first try, it often doesn't give you a blockbuster result. In fact, a lot of the time, it's kinda meh.
And hey, don't just take my word for it. The author of the code we're looking at here literally calls this result abysmal. But this is the lesson. Building models isn't about getting it perfect right out of the gate. It's about starting somewhere, seeing what happens, and then figuring out how to make it better. This isn't a failure, it's just the first draft.
So let's wrap this all up. What are the big things to remember? 1. Logistic regression is your go-to tool for yes or no problems. It's the workhorse for making those binary calls. 2. It works by calculating a probability and then using a threshold to make the final decision. Simple but powerful. And maybe the biggest takeaway of all, building a model is a journey. That 65% accuracy, it's not the end of the story, it's just the beginning.
And that kind of leaves us with one last big idea to chew on. From a medical diagnosis to whether your loan gets approved, these models are making decisions that impact real people every single day. So the question we have to ask ourselves is, when a machine gives us that yes or no answer, what's our threshold for actually trusting it? How good is good enough? That's a question we're all going to have to figure out.
So where's this from? It's all coming from the channel Learn with Praveen.